Well, good afternoon, everyone. Today I'm going to be talking to you a little bit about bootstrapping from backups or reducing your cluster load while you're adding capacity. So this is going to be a little bit of a more technical talk that kind of gets into some of the operational side about what Cassandra does when you're bootstrapping a node or when you're adding capacity to a cluster. So, we'll deep dive in a little bit, but first I'll talk a little bit about who I am and what I do. My name is Ben Bromhead. I'm the co-founder and CTO of Instaclustr. Instaclustr provides Cassandra as a service in the cloud. So, we kind of take care of, provisioning, monitoring, periodic maintenance tasks, backups, wrap it all up in 24/7 support, and we do it all on Amazon Web Services. Google Cloud, Microsoft Azure, they're currently in a bit of a beta with more to come lately. We've got a range of customers. We see a lot of customers in advertising tech space, Internet of Things, but also, from financial services as well. Really the goal of what we set out to do is to make working with Cassandra as easy as possible so that you guys as developers can kind of just point your applications at a cluster managed by us and we kind of take care of the rest. That there ends the sales pitch. And I'll get on to what I actually needed to talk about. So with Cassandra and Scaling, so I guess, we have an existing cluster and we need to add either, more storage or, more capacity to handle more reads, more writes, that kind of thing. Or, increase, the number of nodes that are available for availability requirements because we say, want to increase our replication factor. Cassandra's pretty good at this. This is what it's been built to do from the start. So normally, you set your seed nodes, start Cassandra, nodes join the ring. They start to take responsibility for a portion of the node, of the ring, and then they kind of commence the bootstrapping process. So that's where the joining node starts to stream data from the existing nodes. So when it joins the ring, it takes responsibility for a primary portion of the ring. Remembering that Cassandra, the ring is split up based on the petition key and the petitioner that you set up. Specifically, what actually happens underneath is the joining node actually receives the SS table files streamed from the existing nodes. So it just reads the file from disk and sends it across to the other node. What used to happen in previous versions of it is it would perform what's called an anti-compaction operation. That's where it would look at the SS table and it would pull it apart and figure out, what keys that are part of that SS table are actually due to to go out to the new node. But that's actually quite an expensive operation because all of a sudden you're reading a file off disk and then you've got to write it back and, it's very bad for performance even though you're saving a little bit of bandwidth sending it over the network. So, as I said, streaming is not perfect. Well, it's pretty good. But, there has been a few kind of pain points along the way. You can get some issues with kind of the consistency, violating consistency during range movement. So sometimes your read or write operations might fail because it can't necessarily satisfy a quorum operation if you've got a node down and something's joining or something's kind of gone wrong in during the whole operation. Adding a replacement node can be a little bit tricky, but, they've since kind of improved that. So, as you can see, it's still a bit of a work in progress, but things are starting to get better. But what happens is we've kind of got this fundamental issue with bootstrapping or adding capacity to a node, and that issue is that when you add capacity to the cluster, it actually puts additional load on the existing infrastructure. So, the joining node, it streams data from the existing nodes, which takes up valuable bandwidth and I/O because it's got to read the file from its own disk, send it across the network, that kind of thing. So, I guess for us as a managed service provider, we actually need to make all our operations side effect free. So when our clients say, hey, I need more capacity because, I'm experiencing, an uptick in traffic or for whatever reason, they want to have confidence in us that they can perform these operations and it actually doesn't make their cluster slower. We can kind of manage that a little bit with documentation, tell people to scale early rather than during peak loads. But when people are panicked and they hit the and they see that there's a big add capacity button, they usually click it and think that it's going to fix the problem. So, you know, we really want our customers to not have to worry about any kind of, you know, operation-specific details. So, you know, how do we stop essentially the cluster from, you know, doing something like this? Eventually the guy will fall on his face. So I guess I'll talk a little bit first about some existing solutions that you can use to add capacity in a graceful manner, so that when you do go to add it, you know, the additional load that it places on your cluster, you know, doesn't kind of bring it to its knees. And the first of that is that, you know, there's some capacity planning tools out there. OpCenter has some very good capabilities in this space. You know, it's got a prediction function, and, you know, it's all pretty good. One of the other solutions is also to make sure that your nodes never get stressed and that you actually over-provision by default. You know, it's simple but very effective, but it's also a little bit expensive. The other solution is to make sure that your nodes never get stressed in the first place. And that's kind of to ensure that whatever project you're working on fails. So you actually want to get to a point where you need to add more capacity, because that means whatever project you're working on, it's doing the right thing. If your nodes are already stressed, it's very hard to kind of add capacity. Most often the advice is just to, you know, really just batten down the hatches and wait for it to kind of go away. Cassandra has some very good load shedding capabilities. It will drop messages when it's under stress, and your client will know about that as well. So you're able to handle that in your application code. You just got to remember to make sure that you've tested this kind of behavior, you know, in your development and testing environments. I guess the other one is that, you know, you're some sort of Cassandra wizard and you can eke performance out of it even when it's under load, but it's very hard to do without, you know, rolling restarts and that kind of thing. One of the other current solutions, and Cassandra is very good for this, is actually to have, you know, a multi-DC setup. So what that actually lets you do is when you go to add nodes to the data center that's kind of experiencing capacity problems, is you can actually add the node and you set Bootstrap to false, so it doesn't stream data automatically, and then you issue a rebuild command to it and tell it to rebuild from the other data center. So that's effectively grabbing the SS tables from a different data center rather than the active one. Although the obvious downside with this is that, you know, if you're not currently running, you know, 2 data centers, it's very hard to do, or if you don't have the budget to do it, then, you know, that's obviously an issue. So as I mentioned, all of these solutions have various strengths and weaknesses. You know, they have side effects, or they're potentially very costly. You know, so, and for us internally as well, it still doesn't answer the question of how do we, you know, address making all our operations as side effect free as possible, so that when our customer does go to hit the add capacity button, there's no additional side effects on it. And this is where we've come up with this idea of bootstrapping from backups. So SS tables are immutable. They're also the base unit of data that nodes stream to each other. SS tables are also what we back up by default. So that's one of the things that we provide as a service, is we ensure that your entire cluster is backed up via daily snapshots. And effectively, when you're snapshotting an entire cluster, it's kind of like, you know, keeping another you know, copy of it or another data center, but you know, you're storing it somewhere cheap and easy to get to. So how about what we do is we actually stream the SS tables from the backup location instead of the live nodes. You know, and I think it is actually quite possible. So what we did is, you know, we sat down, figured out how we're going to implement this, and we kind of came up with a bit of a solution based a little bit off what some other databases actually do, how they handle, you know, streaming. So Postgres kind of has a very similar way of actually streaming backups and that kind of thing from backup locations. So what we did is we defined an arbitrary command that can stream the SS table to standard out. And what this does, it's a very pluggable way of actually doing this. So while yes, we run everything on Amazon, and so we, you know, back up to S3, because you can just define an arbitrary command that expects to grab a file and kind of ship it to standard out. You can do it in your own data center. You know, if you've got a SAN where you currently back things up to, you can kind of stream it from that just using, you know, cat or something. Cassandra will then, sorry, there's a bit of a typo on that, will then inject some values into the command, which you can use to help identify which node the SS table is coming from. So you can see that's an example up there. Then when Cassandra actually starts to boot up and when it goes to actually grab, it commences the normal Bootstrap operation. Instead of actually streaming the SS table from the existing node, it kind of short circuits that operation, executes that command with those parameters in it, and it then is able to stream the SS table from this alternate location. And of course that always works because remember that SS tables are immutable and it's also what gets sent over the line. So we're actually not really modifying anything too much within Cassandra, we're just grabbing that file from a different location. So you know, it's a very elegant way to do it because you don't have to worry about consistency or range violations or that kind of thing because the behavior is exactly the same within Cassandra, it's just you're grabbing it from a different place. And also the way that we set it up as well is if the process fails, the node actually just resumes streaming from the existing node as well. So if you're having an issue with your backup location, it just kind of continues on as normal. So you've still got that resiliency and your backup location doesn't become a single point of failure in adding and removing nodes and that kind of thing. So I guess I'll illustrate the process a little bit. This is what normal Bootstrap looks like. You've got the new node down the bottom. It receives SS table 1 from it. As the Bootstrap operations kind of continue, it does this from all the nodes within the cluster. So as you can see, it's taking up the bandwidth, the I/O availability of the existing cluster. When you're running a cluster with backups, usually what happens is you've got an asynchronous process in the background that's uploading the SS tables to whatever storage location you choose, whether that's S3 or a SAN, and then they're sitting there ready to go. When you go to Bootstrap from the backup, we've set it up so that it just short circuits that stream and fetches it from S3 instead. And you can see that it dramatically, reduces how much traffic it's got to grab from the existing nodes because all of a sudden it's grabbing it from S3 rather than your own cluster. And this is just a quick illustration to show that, even if one SS table isn't available, it'll just grab it from, the existing node. And so sometimes, if you've snapshotted your database 24 hours ago and the next backup process still hasn't run yet, there'll obviously be some SS tables that don't exist in your backup location. So it'll still kind of take care of all of that. So how does it actually look like? What's the actual impact on performance? So this is just, I guess, some rough numbers that we did in our early benchmarking. What you can see is around the 25-minute mark. This is a slight dip in kind of operations per second. What we did here, this was a mixed 50-50 benchmark. We just used Cassandra stress tool. It was on some fairly, I guess, budget nodes so that we could really show the impact of the performance here. The dip's a little bit less when you're looking at kind of, the I2 extra large instances and that kind of thing within Amazon. When you kind of start to do it actually from, bootstrapping from backups, as you can see, there is a slight, decrease because, you still got to stream some SS tables, but, it's a pretty flat line. So it has much less impact on your cluster. And I guess, why it actually really matters is, again, I want to talk about the side effect-free bootstrapping, because what it does is it lets you explore reactive scaling rather than having to predict some of this stuff. And so predictive scaling, a lot of effort has been gone into that. So Netflix has a project like Scryer, which goes into load prediction and all that kind of stuff. You can look at what's happening in your front end layer. Are you starting to see an increase in traffic? If you've got historical data, like that during the day, obviously you get more traffic than say at night. Or if you're a ticketing system, that before a big event, before the tickets go on sale, you're going to get a big spike and then reduce it like that. But essentially, at the end of the day, what it does is it makes your cluster more cost-effective to run because you don't have all this extra capacity. You can kind of be a bit more reactive about it. So when can you actually use this? Well, unfortunately not right now. We haven't even submitted a patch to the open source Cassandra project. We will eventually. We're currently running it in beta with a select few of our customers, and they seem to be having some pretty good results with it. We're still not 100% sure about whether stdout is actually the best streaming mechanism. You've obviously got a bit of overhead with inter-process communication, depending on which JDK you use and which underlying OS. Forking within Java can get a little bit hairy. So, so far it's been pretty good for us, but, there might be a more graceful way to do it. Maybe, a plugin architecture where you guys can just drop a jar into the library folder for Cassandra and just call it arbitrary class. The other thing as well is we probably need to refactor a little bit of the stream message workflow, which is the way that Cassandra communicates when it's doing these Bootstrap operations. At the moment, the patch that we've written, it's a bit of a hack on top of it, and that workflow needs to get a little bit finalised. But anyway, that's a pretty quick overview of some of the work that we've been doing to make kind of using Cassandra a lot easier from an operational point of view, and some of the effort that we've been going into, making sure that what we're doing for our clients, is side effect free and, easy and nice to use. So thanks for all your attention today, and I'd like to open it up to any questions if you've got any. Cool, I must have... Oh, no.
Sorry, backups usually... Oh, sorry, thanks. Backups are usually not up to date, so you usually take them like on a nightly basis or weekly or whatever the case. So if you bring a node up and you notice the differences, are you grabbing just the difference from the data center, or I'm guessing you're not grabbing everything, right?
Yeah, correct. So what ends up happening is it only needs to get the difference of the SS tables that aren't already within the backup. So even if you haven't taken backup, say, in a week, again, depending on how frequently your data changes, it's only that small subsection that it has to stream from the cluster rather than the backup location. Yeah. Cool, awesome. I think I might wrap it up unless anyone's got any further questions. Cool, thanks guys, and you can have an early mark. So, cheers.